Welcome to a new episode of Blender and 3D printing, precision modeling with Blender. In this first part, we will discuss the basic ways of working with the object's origin and the 3D cursor in Blender. In addition to the basic working methodology, I would like to highlight additional options for precision modeling with Blender. Working with 3D cursor and origin are the main tools that we need to know to easily and fast create 3D models for 3D printing in Blender. Let's talk about Blender origin. Each object in Blender has an origin. It's the reference point or the starting point, translation, rotation and scaling of objects in Blender. The origin is displayed with this white circle and the yellow dot inside. And for example, if I move the cube a little bit, we can see in the transform section of the properties panel that Blender displays the change of the position. Instead of using the manipulators, I can also directly insert 2 for the y-axis, and you can see the cube is positioned on that coordinate. So if you want to precisely position objects, you can also use the transform dialog and to move your object to a specified location. So we can set the position to any other location in the 3D scene. Sometimes it makes sense to position the origin on the object itself or to individual model parts, but there are some cases where it might be helpful to position the origin outside of the object to any other location. To change the origin, you can go into the edit mode and select a vertex, for example, move the cursor to the selected vertex, go back, use the key combination Shift, Ctrl, Alt, C, and you can set the origin to 3D cursor. Now the origin on the upper left corner of the cube is reflected also in the location section here. By default, the origin is also the reference or starting point or axis for the rotation. If active element is selected by default, Blender will use the origin of the selected object as the reference point for rotation. I can restrict the rotation to an axis using the R key, selecting the axis, Z for example, and then using the numeric input to rotate around the Z axis. The origin can also be set to other model parts. It can be set to edges. Again, I'm using the cursor. It's very helpful for rotation. For example, rotation on the x-axis. Here we can very precisely rotate around a given axis. Another case is, let's select the face in edit mode. Let's set the cursor to the selected face. Switch back to object mode. You can use the shortcut again or also the transform menu in the object menu. Origin to 3D cursor. So now the origin has been placed to this face. Again, so rotate around x-axis. This is especially helpful for translation because now the plane is the starting point. I can now reset the position. For example, I set the position, I can set the Y position to 0. And now the object is aligned to the x-axis. If I want to scale the object on the y-axis, let's select scale and select the y-axis. You can see you can very nicely scale the object on the given axis. Again, you can use the numeric input here and type in, for example, a value. If you want to have control about the measurements of your object, you can use the numeric input, or you use the grid and the snapping functions, or another alternative is to measure the size of your object during the modeling. So let's have a look into the different ways to do it. The first thing is using the numeric input. For example, if I want to change the length of the cube here, I can switch into edit mode. Let's select the face and use the translation function, and let's translate the face 2 units on the positive direction on the y-axis. Therefore I select G for translation, Y to select the axis, and use the numeric input 2 to translate the face 2 units on the positive direction on the y-axis. You can also move in the negative direction just by using a negative value. For example, use G for translation, the y-axis, and -2 to reset the cube to its original size. Another way to precisely change the length of the object is to use the grid and the snapping function. Therefore we go into the top level view and change to the orthogonal perspective using 5 on the number pad, and now we can translate the object. Make sure we have the snapping function activated, use the snapping target closest and switch to increment, so it will use the grid now. And here we can decide if we want to have absolute grid alignment, so no values in between. Zoom in unless you see the subgrid. And now use S for scaling, select Y to select the y-axis, and you can increment the size of your group in steps of the subgrid. So this is another way to precisely change the size of an object. Another way is to use the measuring. There are different ways to measure the size of your object. I prefer the way to use the Measure It plugin that I introduced in the previous videos. Therefore I switch into edit mode, select 2 vertices and use the Measure It plugin in the display section of the tools panel in the 3D view, and here I can say measure at measure segment. It will measure the selected segment between those vertices and show, and then I switch to my measurement unit. So to show the correct measurement unit, I go into the properties panel. In the Measure It properties section I can switch the measurement unit to millimeters. Because I set millimeters as my measurement unit, we can see the measurement, and if I now select the face and I move it, and now I can see the change in size exactly. You also have the possibility to change the global coordinates of the model part. For example, if I change to the global coordinates and set the position 3 on the y-axis, I can exactly move that model part, the face, to the position on the y-axis. These are some short examples how we can change the overall size of the object or move individual model parts with precision. The measurement method works also if you work with angles. So, for example, if I want to have 45 degrees for this angle, then I can select 3 vertices to measure my angle. My requirement is that I want to preserve the overall height of the object, so therefore I cannot use just the rotation. For example, if I now rotate around the x-axis 45 degrees, you see this messed up the overall object structure and measurement. So there must be another way. So I want to preserve the overall height, so therefore I select now the edge. Make sure we have the correct direction activated. So I change this to, let's say, global, and now I can move this edge on the y-axis unless I have 45 degrees. So use the shift key to make smaller steps in combination with the mouse, and now I can set exactly the angle to 45 degrees. Another possibility is, in the same way you move an object in object mode using the 3D cursor to a given location, you can also use this method for the edit mode. If I want to set a vertex on this location, therefore let's split the face. So now I splitted the face. I'm selecting the center vertex, and I can now say selection to cursor. This is another way to precisely move individual vertices or other model parts to a given location defined by the 3D cursor. So we saw different ways to precisely set the position of objects and model parts. So let's continue with the next topic. The origin is also used for different other operations. For example, in combination with the mirror modifier. If we add the mirror modifier to the cube and we set the mirror axis to the y-axis, the origin is used as the reference point for the mirror axis. If we change the origin, this has an effect on the position of the mirrored object. For example, let's set the cursor to the selected object. Let's change the cursor location. I change the cursor location to y-1 now, and I reset the origin. And we see the mirrored object depends on the position of the origin. Also important if you work with multiple objects. The origin of the last object is the reference point or starting point for translation, rotation and scaling. For example, I selected the torus as the last object, and now if I rotate around z-axis, you see the origin of the torus is used as the pivot point. To precisely rotate a group of objects, again you can use the numeric input to precisely rotate, translate or scale your object group. For example, for rotation, let's set the origin of the cube to the lower left corner here. Select the sphere and the circle and now rotate around the z-axis 45 degrees. This allows us to precisely rotate a group of objects to a given pivot point. Keep in mind that this always depends on your pivot point settings. So if you set this to active element, the pivot point is always an origin. But if you set this to the median point, it will be the median between the selected objects. If you set it to the individual origins, it will use the origin of each individual object. And If you use the 3D cursor, it will use the 3D cursor. Let's set the 3D cursor and then rotate around the Z-axis. You can also select bounding box, which is the center of the bounding box of the selected objects. In this first part, we have discussed the basic ways of working with the object origin and the 3D cursor in Blender. In addition to the basic working methodology, I've shown a few ways that we can use to work precisely with Blender. The goal is to get the tools to create 3D models for 3D printing. In the next video, I will again explain various other aspects of this topic, and among other things, I will introduce an additional add-on that we can use to significantly speed up our modeling process. Was this video helpful for you? If yes, I would appreciate if you press the like button. You are welcome to subscribe to my channel and follow other videos on 3D modeling and 3D printing to come up in the future. Goodbye and have a good day.